Good morning everyone. Today we will discuss about the three-phase transformer. So first of all we have to discuss about what is a three-phase transformer. Now we will discuss about the construction and working principle of the transformer. So this three-phase transformer is used to generate, transmit and distribute the electric power. It generates the power on a large scale to meet the needs of industries and commercial establishments. So these three identical single-phase transformers are connected combined on a single core to form a three-phase systems. So based on a various types of industrial needs, step up and step down transformers are employed for the generating and transmitting and distributing the electric power. So in the buildings of a three-phase transformer unit is economically as is consume less material compared to connecting three individual single phase transformers. So additionally the three phase systems transfer AC power instead of a DC and is simple to construct. So we know that the three phase transformer construction, so in similar to the three phase transformer consists of three primary coils and three secondary coils and is represented as a three phase or like we are going to represent as a three phase or like this. So a three-phase system can be constructed using the three individual identical single-phase transformers, and such a three-phase transformer is known as a bank of three transformers. On the other hand, we are going to represent as a three-phase transformer can be built on a single core. The winding of a transformer can be connected in either star or delta configurations. The working of a three-phase transformer is similar to a single-phase transformer, and they are nominally employed in a power generating plants. So in the construction point of view, the three-phase transformer, construction of a three-phase transformer. So in a single unit is used widely because it is a lighter, cheaper and occupies less space than the bank of three single-phase transformer. So these three-phase transformer constructions of two types. So that is a core type. Already we discussed in the single-phase transformer itself. That is a core and shell type. The same way we are going to represent as a core type and shell type. So now we are going to discuss about the core type construction. In this type of construction, there are three cores and two yokes. So basically in a single phase transformer itself, we have to represent as a two limb core. But here we are going to use the three limb core. That means here we are going to represent as like this, the three limb core. Here we are going to use it. There is a three limb and two yoke. So each core has both primary and secondary windings wounded spiral. That means here we are going to one of the winding, that means the three phase means RYB. So based on that we are going to represent it. Each leg of the core carries high voltage as well as the low voltage, because here we are to represent as in a single winding itself we are to represent as a low voltage and high voltage, because the performance is more when compared to the individual of low voltage and the individual of high voltages. We can place this as the low and high voltages. So these core are laminated to minimize the eddy current losses and core and the yoke. So as it is earlier the lamination low voltage windings than the high voltage winding, we know that in the construction of the core type and shell type of the single phase transformer. So as we know, as whatever we construct that the same way we have to represent, but the difference is there we are going to use the two limb core, but here we are going to use the three limb core. So in the LV winding are proportional near, so sorry, the LV windings are positioned near the core with approximate insulations and oil ducts in between them. So whereas the HO windings are placed above the LV windings, which appropriate insulations and oil ducts between them. So based on that, we have to represent the construction of this core. Already we know that. So based on that, we have to represent as, first of all, we have to represent as insulation, LV insulation, then LV winding, then HV insulation, HV winding. In the same way, LV insulation, LV winding, here LV winding, then insulation, HV winding. The same way we are going to represent the primary side and the secondary side. So now coming to the shell type transformer. So same way we are going to represent as the two LV windings lies between the HV winding. So the three-phase shell type transformer is generally constructed by stacking three individual single-phase transformers. The three phases of a shell type transformers are independent than the core type transformer. So each phase has an individual magnetic core. So these magnetic circuits are parallel to each other and the flux induced by each winding is in phase. So shell type transformer is highly preferred as the voltage waveforms as less destroyed. So in this also we are going to represent as a sandwich coils as early as discussed. That means two LV windings, in between we are to represent as the HV windings. That means there is a sandwich type of windings. In the three individuals of magnetic cores we are going to represent it. So in this way we are going to represent either here we are going to represent either LV and again here HV and LV, HV, like that we need to represent it. So in the top and bottom we have to representing the LV windings. In between we are going to represent as the HV windings. In this way we have to construct these shell type and shell type transformer. Now coming to the working principle of the transformer. Now working principle of the transformer. So the three cores are placed at 120 degrees from each other. So if for example I am going to represent as R and this is Y and here I am going to represent as RYB. So each phase displacement is 120 degrees from R to Y, then Y to B. The phase displacement is 120 degrees from the B to R, that is also 120 degrees. So the three phase supply is excited, the currents are IR, IY and IB. So are carried by the primary windings and thus the inducing the fluxes are pi R. The inducing the fluxes are pi R, pi Y and the pi B. So the central leg will carry the sum of all the fluxes and the center leg combine all the legs of the core. So based on that we have to represent it. So based on this, this is the magnetic one of the core and here we have to connect, this is the one of the core and here we are going to connect the another type of the magnetic core. So based on that insulation, so we are going to represent it. So in this way we are going to draw. So here we have to insulations based on that. These are the laminations. We are going to represent it. So in this the one type of winding, one winding, that means RYB. So based on that we are going to represent this is IY and this is IB and here I am going to represent it IR. The three phase systems we are going to represent R and here I am going to represent Y and here I am going to represent this is the B. So based on that, this is the star type of connection here. It will goes to connecting like this. So from this I am going to connect this. So if the sum of currents in this central limit, we are going to represent the sum of the currents IR plus IY and plus IB is equal to 0. So the three phase system, then the sum of all the three fluxes also becomes 0, the resulting in the center leg carrying no flux. So that is the reason we are going to represent as removing the center leg makes no difference for other transformer conditions. So that is the reason we are going to represent as IR plus IY plus IB is equal to 0. So this is the working of a transformer. So now we are going to know, this is the last topic of the transformer. So this is a three phase transformer connection. It is very very important. The three phase transformer connection. So in this three phase transformer connection, so we have a three phase system. In three phases can be connected either star or delta. The three phases are going to connected in the star or delta configurations. In case we are not familiar with those configurations, so we have to represent it any of these configuration, there will be a phase difference of 120 degrees between any two phases. So for example, here I am going to consider this is the star connection. The phase displacement is, here I am going to represent as, the center point must tie either all. So this is a neutral point. Here this is the star connection. Here we are going to represent as the delta connection. So this winding of the three phase transformer can be connected various configurations, either star to star and delta to delta, star to delta, delta to star, and the open delta. The lastly we have to represent, that is a Scott connection. So these are the configurations we have to represent in a three phase systems. So first of all, I am going to discuss about the star to star. So in the star to star connection is generally used for the small and high voltage transformers. In delta to delta, used for large low voltage transformers. In star to delta, first of all, we discuss these two, then we can understand easily for the star and delta. So in this star and delta, so we are going to use this is small and high voltage ranges, and for the delta to delta, large and low voltage ranges. In star and star, so in this particular star connection, the number of required turns per phase is reduces, as phase voltage in star connection is 1 by root 3 times of 1 by root 3 times of line voltage. So thus the amount of insulation required is also reduces. So the ratio of line voltage on the primary side and the secondary side is equal, then the transformation ratio of the transformer. So the line voltage on both the sides are in phase with each other. The line voltage on both the sides are in phase. So this connection can be used only if the connected load is balanced. The load is balanced, then we can use this star to star connection. So now I want to draw the star to star connection here. So basically we have three individual windings in the primary side as well as the secondary side, right? So in this we are going to represent the I am going to represent this is R and this is Y and this is B. So in this I am going to represent as a star connection. That means this is neutral terminal is connected to this one, then this neutral terminal is connected to this one. So based on that only we have to represent this star, and the same way here I am going to connect this one to this, then this to this. So based on that we are going to represent this one. So for example, I am going to represent the input terminals RYB. Here I am going to represent as R dash, Y dash, B dash. Like this is we are going to represent as star to star connection. The same way we are going to represent as the delta to delta connection. So I am going to represent the three individual transformers. The delta connection means here I am going to represent the second of that one is connected to here. The second is connected to here. Then simply we have to know that one is, for example, this is A and this is B, then this is B dash, this is C, then this is C dash, then this is A dash. So based on that we are going to represent A is connected to the A is connected to the, for example here this is C dash, and this is B and this is B dash. So this B and B is connected to this, then this is R and Y and this B. So based on that these terminals are connected to this one. Then similar manner we are going to connect it like this. This is goes to like this, and this will be connected. This is all about the delta to delta connections. So in a similar manner we have to represent as a star whatever we are going to previously, that is star and delta, then delta to star, and the star is the star to delta connections are connected with the ground neutral, and the secondary windings is delta connected. So this connector is mainly used in step down transformer at the substance end of the transformers. So these connections is mainly used in step down transformers, and the ratio of the secondary to primary line voltage 1 by root 3 times of the transformation ratio. So there is a 30 degrees phase shift between the primary and secondary line voltages. The same manner we are going to represent as a delta to star, but in the star to delta, that is the line voltage is 1 by root 3 times. In this delta to star, the line voltage is root 3 times of the transformation ratio. So based on that we are going to represent this star delta, delta to star. Then another one is the open delta, that means V to V connection. So the two winding transformers are used and primary and secondary connections are made as we are going to represent it. So that is a V to V connection. I am going to represent it. So one phase winding we have to remove it. So this connection is going to represent like this. This R, Y, V. So here also we are going to represent it. Small R dash, Y dash, and V dash. So the two transformers are used and the primary and secondary connections are made as the whatever I'm drawn this one. So the open delta connection can be used when one of the transformer in delta bank is disabled. So whenever we are going to represent as a delta to delta connection, so one of the transformer in delta to delta bank is disabled and this has to be continued until the faulty transformer is repaired or replaced. So it can also be used for small three-phase loads where installation of full three transformers bank in unnecessary. The total load carrying capacity of open delta connections, that is 57.7%, then that would be for delta to delta connections. Then this is the V, otherwise we can represent as V to V connection also. Then last one we are going to represent as Scott connection, that is T to T connection, that is T to T connection. This also we are going to represent as like this, the two windings, but here we are going to connect sorry. So the two transformers are used in this type of connection. So one of the transformer has center tap on both the primary and secondary windings, which is called as a main transformer. So the other transformers is called as a teaser transformers. The Scott connection can also be used for three phase to two phase conventions. The connection is made as like this. So based on that we are going to represent as a TT connections. So this is all about the connections of the three phase connection of a transformers. So thank you.